All right, welcome to the Monday MIDAS seminar series. This might be the last one of the term, I believe, James, if that's correct. So we had a fun semester of speakers coming through, and Ben is our speaker this week. Ben got his PhD in computer science from NYU. By the way, I don't know Ben personally. I Google him and I know him through his friends and some folks that he works with. He works at a company called 2 Sigma. And actually, 2 Sigma has a great kind of a program that sponsors some graduate students here, and well, not just here, but all over the country, actually, in terms of data science and basically using their skills that they develop here in graduate school for things on their theses as well as anything else you can put your mind to. Ben is a TED speaker. He's given a TED talk I watched the other day. It was on finding the worst parking space in New York City. So it's an interesting topic to talk about how data science is used in a way that maybe is not so obvious to some of us, and hopefully that's what Ben will tell us about today on his open data work that he's doing. So Ben, please go ahead.
Thank you. Hi, everybody. As I said, I'm Ben Wellington. I do work at 2 Sigma, where I am an analyst there, but I'm actually talking to you today about what I'm doing outside of my work day to day there. My background is in natural language processing, so I'm a big computer nerd, but along the way, I've started to get into some other stuff. So I'm going to tell you about that today and the journey, how it brought me in and shaped this. So let me share my screen briefly. All right, and let's do this, and off we're running. So I'm also a visiting assistant professor at the Pratt Institute in Brooklyn, where I teach in the urban planning program, and I teach urban planners about statistics, which is kind of a random combination, but that's what we're going to talk about today. So first, I would argue that I call myself sometimes a data storyteller. So what does that mean? That means that I've learned over time that you can do all the science and math you want, but if you can't explain it to anybody in a way that's functional or that people understand, then there's no real point, right? People don't necessarily get much out of it. So this all started for me back when, as I said, my background was in computer science. I was a data scientist, even though it wasn't called that back then. Sort of a new term over the last decade. And at the same time, I married an urban planner. So my wife had a planning background, and she would talk about urban planning stuff, and I would talk about data stuff. And at some point, these two things were sort of bound to kind of run into each other, as marriages seem to. So what did that look like? Well, in New York, this was kind of made possible by this open data movement. It's a global movement. I would say that it really started to pick up after the Obama administration came in, and President Obama's first day in office, he signed this Transparency in Government Act, which basically created what was called data.gov. It's a place where the federal government posts a bunch of data. Soon after, a couple years later, I think this is by 2012-ish, New York was also signing its own open data legislation. And what is open data? It's kind of neat. It's this idea that all data is public unless there's a reason for it not to be. It's kind of a spin on things, right? So imagine if you had a right to see any data collected by government, unless you shouldn't. Why shouldn't you? Privacy, security, there's all sorts of reasons you shouldn't. But what if you have none of those reasons? What if the default was this is accessible unless otherwise not? That's the opposite of the way most of the world operates, right? If you need information, you have to go get it. But imagine if information were just there at your fingertips. That's what open data is meant to bring us. So at the time, then Mayor Bloomberg said basically that across city government, agencies use data to develop policy, implement programs, and track performance. And each month, our administration shares more and more of the data with the public at large, catalyzing the creativity, intellect, and enterprising spirit of computer programmers to help us all build tools that improve our lives. Now, this, of course, is this view that computer programmers will save us all. Turns out maybe it doesn't really work that way. But if we create data, computer programmers will come and help us. And what else they do? They ran these, and they still do have these big app competitions. So let's see who can come up with the best app. And as we know, like there are apps that use public data, mostly transit apps, right? But it turns out transit apps also don't save the world. So there was more work to do. I was always struck by government's view of this at the time, which was that this is about computer programmers, that open data is about programmers. And I'm here today to challenge that, to convince you that it's about everybody, that it doesn't, especially those who are even more, it's literally everybody, but even more so the more data literate you are, right? That anyone with a small amount of data literacy can do a lot. The more you have, if you're involved with a data science program, then you probably can do even more, right? But you don't even need to be a data scientist to access that. Being one makes it all the more exciting, as we will see. So while I kind of believe the government had this view of data going through programmers to apps, I think that it's much more about data going through all sorts of avenues to get to the public. This has taken the form of open data portals around the world globally. I have spent a good deal of time looking at every data set for every large metropolitan area in the United States, which is a lot of scrolling. There's some fascinating gems in there, but a lot of cities, maybe like half the top 100 biggest cities have open data portals that are pretty interesting. Some are quite comprehensive, and some are less so. But New York City has over 1,000 data sets of various quality, and you can find it just by searching. Across the top here, you can see this is something called the Open Data Census, which was run by the Open Knowledge Foundation. I think though it is, I don't think it's maintained any longer, but it gets a good idea across. Just across the top, you have these different areas of data, and from up to down, you have these different cities and how open they are, and it allows places to rank against each other. And of course, open data is not just a United States thing; it's a global thing, more so in some countries than others. But again, it is a global movement to unleash data into the hands of people. So what do we do with that data? Good question. We try to analyze it. Right? That's what data scientists do. But that's what really anyone can do. I'll show you this as an example of me learning something called QGIS. QGIS is the open source version of ArcGIS, which is a spatial program for doing spatial analysis. So this is me just teaching myself and doing silly things. And this particular data set was bicycle collisions in the city of New York. So you can see over here, this is Manhattan. So this is the densest part of New York City. And here's Brooklyn down here. And there are these bridges here, the Brooklyn Bridge and the Williamsburg Bridge. And with the Brooklyn Bridge over here, the Williamsburg Bridge, the Manhattan Bridge. And you can see that this is where bicycle collisions happen most often. And these are typical of ones that are reported to the police, so they're probably serious enough that they're being marked in our data. And you can see this red here shows where these collisions are happening, and it's just me exploring things. But I found that as people tend to commute from Brooklyn, one of the outer boroughs of New York City, into Manhattan by bicycle, so you can see that as these bridges come over, which are heavily ridden by bicyclists, that they bring with them accidents or collisions. I shouldn't say accidents. And it showed there were certain areas that had more than others. That this is a road that has elevated subway tracks. So the train is above the road, which is a visibility nightmare. And hence you see a highly elevated, not just tracks, but elevated collision counts in this Roosevelt Avenue section. But I want to point out something about this. Specifically that this data actually was not necessarily open data at first. It was in one of these. We all know that logo. It brings joy in the hearts of many. This is a PDF, right? This is where data goes to die, I would argue. It is an interesting format to publish data. If you as a government were required by law to publish data and you didn't want anyone to read it or use it, sorry, you might put it in a PDF file. And that is exactly what the police department did for many years as they published vehicle collisions in PDF files. So you would open up this monthly report from the police department, and it would be hundreds of pages of PDF of a table, literally a PDF of tables. I'm not making this up. looked just like this. Luckily, there was this guy, John Krause, who wrote this thing called the crash data band-aid, and every day it would go and it would download this data and make a CSV file and then post it on his own personal website. So he mirrored it. Before long, the police department was like, well, I guess we should probably own this process and not have someone else do it. So they started posting it as well. And today, this data is very, very much available. But sometimes it takes some advocacy and some pulling to get there. I call this kind of semi-open data, right? Because we put data out there, but not really. And it just uses a lot of public's time to make the data actually public, right? There's public and there's public. There's a difference. If you have any doubt, by the way, that New York City doesn't understand the difference between a PDF file and a CSV file, I found this gem in a lawsuit from New York City suing Verizon. They were angry at Verizon for not delivering broadband the way they were supposed to, the fiber optic internet to the, not broadband, but fiber optics to the city. And they sued because they were very angry because Verizon would just keep them giving them PDF files instead of CSV files. So that does prove that New York does know what it's doing, that it's not out of not knowing. And okay, so moving on, this is an old chart, and I have it just for illustrative purposes, even though the numbers are different today. It's a kind of chart that like might appear in a government report, might appear in a news article, someone might make it. And I always, every time I see a chart or a table, I'm always fascinated because you have to ask yourself, you know, what was the narrative of this? Why did this person choose this data to show us? Every single table or chart, mostly charts, every chart you ever look at is somebody else's narrative being fed to you. Doesn't mean that they're bad, doesn't mean that it's not a good thing, but it's fed to you, right? So the nice thing about open data is you can ask your own questions. And in this case, the data that New York City had was taxi drivers driving around, dropping off people and picking up people. And it has a timestamp and all this stuff. And I always wondered, you know, can we do more with this data? So I had a question, and it was essentially, when is rush hour in New York City? You know, what time is it? So I decided to look at the speed of every taxi driver, every taxi cab throughout the day and just chart the average speed. Interestingly, this was made quite easy because it ended up in if you've ever used Google BigQuery, it can do massive amounts of computation very quickly. And it's actually it's uploaded for the public to use in BigQuery. So anyone who wants to play with taxi data can do that. But here's what came out. You can see that essentially taxis are fastest at 5:18 in the morning. And then they slow down till at 8:30 in the morning, they're going 11 miles an hour, and they stay that way all day, right? So there's no rush hour in New York, just a rush day. It's good to know. And as silly as this is, you can start to understand that you can customize this kind of work, right? If you want to understand how long it's going to take you to get from your house to the airport on a particular day of the week at a particular time, you now can have a statistical distribution. And I literally, you know, will say to my wife, well, if we want to be at JFK by 11 a.m. and we want to be 95% sure we're there by 11, then we must leave by 9:47, because that's what the data shows, right? You can actually get a distribution for every trip and plan your risk tolerance accordingly. I guess I am much less risk tolerant than my wife, who is fine with the 50% mark, but I'm going the 95%. All right. I want to point out that this data is also was not freely available at the time. You had to file a Freedom of Information Law request, which basically is, hey, government, please give me this information. And they had a little website you'd go. And at the time, this guy, Chris Wong, went and he got a hard drive. And he brought it down there, and it had to be it had to be a wrapped, unopened hard drive, and they would put data on the hard drive and they hand it to you. But he did something interesting with it. He took the data, and unlike most people who file these requests, he put it on the internet. It's kind of like unexpectedly. It surprised the city that this data would be on the internet. Suddenly, there it was. So I call this kind of semi-open data again, right? The data's there, you can get to it, but you have to figure out what you want to ask for. You have to even know it exists to ask for it, right? The problem with Freedom of Information Law requests is that you need to know that they have this in order to ask for it. So some people file FOIL requests to ask, what type of data could I file a FOIL request for? And then do a follow-on FOIL request to figure out what is there. Right? It's a very opaque process. But it does move forward. Okay, those are some of the challenges of open data, but let's move to some of the interesting stuff we can do with it. And I did so by combining kind of this data science and urban planning take, and I started this this blog. It's called Quant NY, as in my goal was to quantify New York, and I realized that there's all this data on this open data portal, but maybe people weren't using it. Was anyone using it? I don't know. There was laws passed, it was out there, but I never really saw it used, and this bothered me. So I started just doing stuff. What did I do? Well, I made that funny map I showed you, okay? And I published it. Why not, right? I was interested to see what would happen, and something fascinating happened. People started to write about it. In fact, somebody said I called Williamsburg a death trap in that blog. I didn't say that. Just write that. I didn't say that. So I remember there was one article that headline was, it was out of Williamsburg, was this area, and the headline was Killingsburg. I was like, oh. So you have to be careful in data, how people interpret your results, right? Next thing you knew, I was in the Atlantic. This was exciting. And I was like, I literally went to like file save as heat map, and I'm in the Atlantic. Like, this is so fun. I need to do more of this. And I started to spend my evenings and before I had 3 kids, I had more time back then. Spend my evenings publishing, different explorations of data, and I started to notice there were certain things that got more people excited and more people into it. And I want to share that with you today, because again, if you write something but you can't communicate it out, then if you find something exciting but nobody can understand what you found, that's not going to help you, right? So I asked myself, how can I, what is it that makes people excited? So I kind of saw, look, I have this topic area, I was doing some urban planning, I had my data science, but what really was this key? And I'm gonna give you this reveal here. You're not gonna see this coming. And I'm half joking, half not, but I'm gonna say improv comedy. Okay, what am I talking about? First of all, every talk needs a Venn diagram, but we'll put that aside. At the intersection here, I'm gonna call this data storytelling, and improv comedy is just my frame of reference on storytelling and like communication, because I happen to have done improv for a long time. I was an improv instructor. I taught workshops. I was on a bunch of improv groups, and there were things that I learned about how to communicate, about what makes a good and interesting, engaging scene, that I started to carry over and notice more in some of my data work. So I'm going to teach you today about how data science and improv comedy, what they have in common. Let's see. First of all, details matter. If you are in an improv scene, you say, hey, can you pass the cereal to me? It looks great. You can do that. But if you say, can you pass the Captain Crunch? It's much more vibrant offer to somebody. You always want to be specific in a scene. It's a gift to everybody. And I think that detail-oriented approach, being specific and looking over things, is something important in data science. I recently was giving a talk at Turner Construction, and I was curious when I was looking at them. I was curious if I could find some data on Turner, right? Because I was doing this talk. So I decided to look in the building permits of New York City, which are public. There's a great corpus of great data set of building permits. So I went in and I started saying, all right, let me just look up Turner and see all the building permits, and I can make a map or something. But what did I find? Well, let's see here. Is this going to work? Turns out that if you are Turner Construction, you're a pretty big company. Turns out that your building permits can be filed with many different names, right? I'll just let you take that in. I find it a thing of beauty. It's kind of fascinating how many ways you could abbreviate the exact same thing. And yet here in this database, these were all separate entities, right? So if you were to do some sort of counting, you had to clean this up. You need to be detail oriented. You need to kind of look and massage and understand your data. I then said, well, fine, but let me look at the phone numbers they used. By the way, there's 250 spellings, okay? Then I said, well, let's look at the phone numbers that are used. And sure enough, there was one primary Turner Construction phone number. So if you need to call them, there it is. But apparently they use a lot of phone numbers to register these building permits. So that didn't work. Well, then I said, well, what about the people who are actually behind them? Because it's not just a company filing, it's a person. So there's this person, Norbert Ram, I don't know how to pronounce it, but Sure enough, it didn't work so well, because I realized that even there, turns out that Norbert is can be spelled in many ways, including Mr. Bert, or Norbet. So then I was like, well, let's take the last name. Last names don't have abbreviations, right? So I looked up this particular person who had a bunch of permits and realized that that too is problematic. You know, what's the moral there? The moral there is you need to sometimes dive in and read what you're looking at. Don't treat data set as a black box that you run something in some pandas script and you get an answer, right? You need to look, you need to explore, you need to get to know your data, become friends with it. You and Mr. Burt. All right, so another thing about doing improv and communicating is that it's important to connect to people's experiences. So oftentimes, you know, you think about who your audience is and what's meaningful to them, and depending where you are, who you are, you might shift your scene accordingly. But there's certain things that are kind of universal, right? Like if I do a scene and I'm brushing my teeth in front of the mirror and talking to somebody, that's like a moment that people relate to, and that's gonna like trigger a lot of feelings and interest in them. So, you know, when I was writing, I just said, what are the things that just people see around, you know, when they're in the city, in New York City, where I live. And I don't know, there's a bunch of things I've noticed. A lot of times people would talk about this problem with our taxis. And I've just noticed people brought it up over the years, where here's what happens. You go outside, you go to try to get a taxi at like 4 or 5 p.m. and they have a little light on the roof in New York that says off duty. It's very weird. You think they just turn off their light, but no. Instead of turning off the light on top of the tub, they add another light that says, my light's on, but I'm off duty. And off duty means in theory not going to pick you up, but they might pick you up if you're going in the direction they want you to. So they open the window and they're, where are you heading? You say, I'm going that way. And then, right. This is a common occurrence if you've taken a taxi in New York City, and it always is around 4 p.m., 4 to 5 p.m. So first I want to see, is this real? So I took the number of dollars per minute the New York City taxi fleet was making, and you can see, sure enough, at around 3 to 4 p.m., there's a big dip. That's obviously a supply and demand gap, where all those people who are being turned down on the street would fill in that little, you know, that little, and that's about 3 to 4% of the revenue of the entire taxi fleet, right? Okay, so there's some interesting questions though. First of all, why does everyone do it at the exact same time? Why does everyone do it at the exact same time? Because well, it's kind of weird. All right, so uh-oh. Sorry, I have a kid at my door, but my door's locked. I'm telling you. All right, they're gone. All right. So why do they all do it at the same time? And it's a really weird reason. It's because there's only one time of day. Okay, first of all, a couple things. The taxi shifts are 12 hours in New York. So you might go and rent your taxi for 12 hours, and then you hand the keys to someone else, and they run it for 12 hours, and you get the keys back. So that way the taxi's always running. Okay. So, and the other thing is, when you go and change your shift, you might have to drive to your garage. Your garage might be 20 minutes out of the city because real estate prices in Manhattan are very high. So you have this 20-minute, 30-minute drive. You go hand the taxi keys to someone else, and they drive back. And this seemed to always happen at 3 to 4 p.m. So if everyone's changing taxis at the same time, that's not efficient, right? That means that you can't keep up with demand because everyone's switching tax. So why is it all at the same time? This is cool. There's only one time of day where the total demand is equal in the previous 12 hours as the next 12 hours. Let me explain that. If I said to you, hey, let's split a cab. I'm going to drive 8 a.m. to 8 p.m. You drive 8 p.m. to 8 a.m. Fair deal? Are you in? Well, that doesn't sound fair. The 8 p.m. to 8 a.m. shift does not sound like a very lucrative shift, right? But if you switch, like, I don't know, 4 o'clock, I'm going to drive 4 a.m. to 4 p.m. You get 4 p.m. to 4 a.m. That feels a little more fair, right? So I plotted the rolling 12-hour previous fare with the rolling 12-hour next fare versus the time of day. And the intersection, which is essentially where the next 12 hours of revenue is equal to the previous 12 hours of revenue, was, yeah, between 4 and 5 o'clock. So I guess there's some logic to all this. The data shows it. How did the city respond to this? Well, they added a surcharge so that if you ever drove at rush hour, you'd have to pay extra money. You pay an extra $1. And they figure if we add $1 at rush hour, we're going to have more drivers because more money, supply and demand. So then we all pay this dollar surcharge during the evening rush. But what did that do? That moved the intersection of the two from like 4 something to 5 something, which actually made the problem worse, because now the only fair time to split our cab is rush hour as opposed to right before rush hour. And yet we still all pay this dollar charge today, even though it didn't help, because that is the way things can work. I got to give this presentation to the Taxi and Limousine Commission in New York City at some point, and that was exciting, but not sure if it went anywhere. I want to skip this one. Also, not just keeping, this idea of focusing on a single idea, right? If you're doing an improv scene and you're like, I'm the Queen of France and I only have one arm and I have this and that, right? It's very complicated. People see data sets and they're overwhelmed sometimes. There's so many columns. There's so many columns. What am I going to do with this? How do I possibly look at a data set with so many columns? The answer is you pick a few and look for a narrative. We have a bike share program in New York City where, as many cities do, and that data is interesting. You can see what time someone leaves that grabbed the bike, how long they were riding for, their age, all this stuff. And sometimes that feels like a lot, but I was just curious the gender of the rider. So I made a map of stations and the percent male and female of different stations around New York. And so this is Midtown where it's very dense. And you can see that there's a higher male ridership of our bike share program than in other areas of the city, which were less dense. Here's sort of Wall Street, again, with a higher male contingency. That's an example where there's a lot of information, but you just choose one angle and you look to kind of focus that. And people have visualized bike share programs with all sorts of floating charts and graphs and fun things. But I try to just, if you look at a chart and you walk away and you don't know what the narrative is of it, or a graph or a map, then it might be time to rethink that. Maybe it's a little too complex. I'll also show you this sort of simple example. This is the number of robberies per hour in New York City. What's a robbery? When somebody takes something by force from you. And it turns out that I always assume that most robberies happen late at night, maybe when the bars close or something. But it turns out that the most robberies happen between 3 and 4 p.m., which struck me as very strange. And I said to myself, what happens between 3 and 4 p.m. that would make a spike in robberies? And one thing that happens between 3 and 4 p.m. is that schools get out. Well, if that was the problem, then if I split my map into vacation days and non-vacation days, I should see a different chart, right? I shouldn't see the spike on vacation days because kids aren't all getting out of school at the same time. So if this really is about kids getting out of school, it should show it when I split it. So I split it. The blue line are school days. The red line is vacation days. The green line are weekends. And you can see, sure enough, there's my late night bar robberies tend to happen between midnight and 4 a.m. on weekends. You can see all the way on the left in green. But unfortunately, the school robberies tend to happen between 3 and 4. This is a great reason why open data is helpful. It used to be that you would get a monthly count per precinct. Now we get individual crime data. You can ask all sorts of questions. You can see how weather affects crime. You can take this type of data and you can go down to a single neighborhood and see where we need to invest in after-school programming, right? If you're a nonprofit in that space, right? We're finally able to interact with our city's information to make important decisions about policies and how we want to build things out. So, it was kind of a upsetting finding, but one that shows the importance of having access to this kind of information, because you're not going to see this in a report from our city, unfortunately. Okay. And actually, I'm gonna skip over this one. I'll also say that people have their own expertise, the things that they've noticed or they've done or they're aware of. And I always say, whatever you're bringing is a great place to start. Take the things you've noticed in the world and try to see what you can do to use data to make them better, right? Take where you're from, things you've learned, your profession. A lot of times you have an observation, you say, oh, maybe I can measure that. The answer is maybe you can, and that's a lot of where my work came from. I happen to notice in New York that we have these fast food chains, but they're not just fast food. A lot of the time they're combined because real estate prices are so high. So instead of having like a Taco Bell and a Pizza Hut, there's like a Taco Bell Pizza Hut, and it's one building. And I would say, like, generally, not that I'm frequenting fast food, but if I were, maybe the combination places were less, they seem less, I don't know, well kept than maybe their partner ones that were not combinations. So this is the kind of observation where it's absurd, but I could actually quantify it because New York City has health inspection scores. So I decided to measure the inspection scores. Now we use a letter grading system, so anything less than a 13 is considered an A in New York, meaning you have less than 13 violation points on your visit. And you can see here, Dunkin' Donuts and Baskin Robbins. Dunkin' Donuts gets a 14, Baskin Robbins gets a 13, but anything that's both gets a 16, so it's slightly worse. But this is like where it gets fascinating. Taco Bell is an 11, which is like an okay A. KFC gets like a high B, a 14, but their combo is through the roof. So what's my point here? It was an absurd observation that I can suddenly quantify, which can be exciting. By the way, when I was in there, I decided I have to at least rank all the fast food in New York and from least to most, violations. And there was IHOP in last place there. And this place called White Castle in first place. I don't know if you know much about it. It's known for its kind of late night. It's not known as the, creme de la creme of cleanliness, but I'll never forget when I wrote about this and the local Fox station went out with a camera crew to the White Castle parking lot and they're interviewing somebody. And I just never forget, they're saying, well, how do you feel about this? And she's like, I always knew it was healthy. And I was like, oh, what have I done? I never said that was healthy. So it is hard to shape how people interpret your data, right? Even if you do your best. And then one example before we talk about some of the impact it's had. It's so important to be very thoughtful and stop and think about the units and how you explain something. And this is my favorite example of this is from this map. The map's not very pretty, but I think the story it tells is interesting. This is New York City again, and I was just looking at waterways and specifically the amount of sewage in our waterways. Why is there sewage in the waterways? Well, because there's a stuff called fecal coliform, which helps you measure sewage. And what happens is when it rains, and people flush their toilets, it all goes into the same system. It's called a combined sewer. So the toilets and the water drains go in the same system, which is fine and efficient until it rains really hard. And then the system can't keep up. And so they have to it overloads and they dump it into our waterways. It's great. A lot of cities do that, unfortunately. But that's the story of how we get it. What's the data science point? Well, this data is kind of interesting because how do I explain to someone that having 15 milligrams per milliliter of fecal coliform is a lot? How do I explain that to somebody? No one's going to care how many milligrams per milliliter is in their water, right? So if I were to go and I would have mapped for you the number of milligrams per milliliter, you would walk away having no idea what I'm talking about, but sure, sounds interesting. So what are the units you care about? Because it's not milligrams per milliliter of coliform, I guarantee you. So this is where you have to stop and say to yourself, how do I convert this to care about units? What are my care about units? In this case, I converted it to number of days it would be illegal to swim in the water on New York state law. Number of days it would be illegal to swim. That I can talk to people about. When I go to them and say, hey, there's 94% of the time I took a sample on this particular waterway, it would not be legal for you to be in that water because it was so dirty. That's going to leave much more of an impression than, did you know there was 43 milligrams per milliliter? So, another thing to keep in mind, what was interesting is that about 5 years after I wrote about this, I always stare at the data and wonder, is anyone in the government looking at this? And what are they doing with it? And obviously the answer is yes, but are they looking at the outliers? Somebody must know that this water is this dirty, right? And there's a reason. This isn't just from the storms. This is a real problem. And I see stories 5 years later like this. Apartment dumps 200,000 gallons of sewage per day into Coney Island Creek. And I'm like, yeah, we know. It's said that in the data for a very long time. Why are we just discovering this now? So every time I look at these data sets, I'm left wondering, don't just assume people see things. Don't assume it's someone else's job. Data scientists can bring to light things that even the people care about, they might not, and it's not even just data scientists, actually just curious people with that can do a pivot table in Excel can bring things to light, right? Just by taking the time and asking questions. And lastly, I'll say thinking outside the box is obviously an important attribute in performance and improv. Sometimes it's really rare there's a data set that's just labeled with the thing you want. The solve my problem data set never exists, right? We know that. So I had an example once where I was wondering when people decorate for Christmas. And despite my searches of open data portals across the country, there was no when do people decorate for Christmas as tracked by the government data set, unfortunately. So what do? You look for proxies, you think about it. What are creative ways one can do it? And here's a wacky creative way one can solve this problem. It turns out that every time someone goes into, not every time, but sometimes people go into an emergency room, the things that injured them are coded up and represented. And that's how we get these statistics like this many people are hurt by ovens and gloves and whatever else hurts people. But it turns out that there's a special code for Christmas decorations. So we can actually see the number of people per week that go into ER that are hurt by Christmas decorations. And I imagine that that's got to be related to putting up Christmas decorations, right? It's one of the more common ways to be injured if you've ever seen National Lampoon's Christmas Vacation. All right, not that I think any of you have. So what do we have here? This is Thanksgiving. Thanksgiving is when people start putting up the decorations, apparently. Why are there 7 bars for Thanksgiving? Because this is over many years, and this is day of month, and Thanksgiving could fall in one of 7 days, right? So you can really see the uptick in Christmas decoration visits to ERs starting at Thanksgiving, peaks about the first week in December, and then comes back down. You see a lull right before New Year's, maybe not surprising. And then you can see like maybe I took down the Christmas decoration entries, tend to spurt back up right after New Year's. So you can see that little bump. So I learned a few things. I learned that it's safer to take down Christmas decorations, put them up. But also, thinking outside the box sometimes can be interesting ways to solve, real problems. All right. So we're gonna go with that to what does all this mean? Why does this matter? How do I make an impact with all of this? Well, if you can get your point across, if you can communicate it in a clear way, then suddenly people listen, right? It's fascinating. It doesn't have to be, and by the way, like at 2 Sigma, yes, I'm doing, deep statistics on things. I'm using, machine learning and neural networks and all this stuff, and that's fine. And like, there is space in the world for that. But sometimes descriptive statistics can tell a really compelling and interesting story, right? If you can pair it with a narrative that people can understand. And so that's what I started to do. I started to write these posts, and I would write about things like, for example, remember how I told you about those restaurants in New York City with health inspection grades? Well, this is a map of all the grades that they've gotten in histogram. So how many restaurants got each grade? So 13 and lower, you get an A in your window. If you get a big A in your window, that's good for your business. You get a B in your window, big B, it's okay for your business. If you get a C in your window, not great for your business. So what do we see? We see a lot of restaurants get like 11 points, 12 points is the most common number of points violations, 13. But what happens at 14? It falls off a cliff. How do all these restaurants know that, you know what, I'm gonna get 13 violation points, not 14 today. I'm gonna like clean this one thing just to nail it. I want my lowest A possible, but not my highest B, please, right? I mean, I imagine the restaurants aren't controlling that. I think if you got a saw and you chopped off the top of this histogram, it would fall into this space beautifully. And you'd have a normal, I mean, not normal, but you'd have that's the wrong word to use in statistics. You'd have a reasonable looking curve here. But what's happening? Well, we probably have some grade inflation going on. The inspectors are feeling a little guilty. Look, if I see this evidence of mice and I don't realize, if I write down that there's evidence of mouse this last time, then you're gonna get a B, and so we're gonna, so there's clearly grade inflation going on. You can see it between B and C as well. It's not a Stark, but it's there. And this might seem silly, but I further have shown that this is more aggressive depending on the cuisine type, so that certain types of restaurants get a little more help than others depending on their ethnicity. So there are problems here. What do we? I wrote about this, by the way, and the Department of Health put out a quote, and they say, "Well, inspectors are not instructed to offer leniency just to cite what they see. The finalist score is based on the extent of the violations that the inspector observes." That was not a very helpful statement. It didn't address anything I was pointing out, but it is a government quote. All right. What else have I found? This is a great one because for the longest time, the New York City budget was only published in PDF. And not just to the public, but to the legislators voting on it. So imagine you work for the city council and you have to vote on a budget. And you either get a stack of papers or you get a file. Like, hey, you got to vote yes or no on this. Well, it's literally thousands of pages. How am I going to vote yes or no? Like, what's in here? How do I understand it? You're not given any tools to do that. I know this because my wife worked for a city council member. You're not given any tools to understand the budget. There's no way to look at it or sort it or explore it. So it wasn't until 2017 where the city started to, actually, no, this is 2018. This is another one that was scraped before we scraped this one out of PDF. So in 2017, we scraped some data out of PDFs with that same Chris Wong character who did the taxi data. And what did I find? I found that the NYPD, the New York City Police Department, had this budget line item called protection of foreign missions. And they labeled $791 million for that, which sounded a little weird. How did I find it? Outliers, right? Outliers are always stories, by the way. You ever want a good story? Find the outlier in data. It's either bad data or a fascinating story. So I dug in here, and it turned out that was like a typo, that it was supposed to be something else. But this is the budget that everyone voted on. They all voted on it. They were handed a file that said, we agree that we should spend $791 million on protection of foreign missions. And they voted on it, and they all said yes. And then the administration later was like, well, that should have said something else. It's a little weird, right? I'm not saying that it was on purpose, but I am saying that giving people tools and data to understand something, like the fact that you can accidentally say oopsie on $791 million is a little disturbing. This is a great one where the de Blasio administration responded, we are working on fixing this misprint. All right, thank you. It's a good quote. I'm gonna skip over this one. But I will tell you a story of, when you ride in a New York City cab, you're given a screen at the end of your ride, and it says, hey, do you want to tip 20, 25, or 30%? And pick, there's great options. You can also pick other, and you put in your own tip, and that's fine. Did you ever stop and think 20% of what? What was so interesting is that there were two vendors of these cabs. The Creative Mobile Technologies was tipping on top of your tolls and your taxes. So you go through a toll and then you hit 20% and you tip on that. The Verifone, who was the other vendor who made cab payment systems, was not programmed that way. So the cab drivers who drove Creative Mobile Technology cabs were getting paid $300 to $400 more a year in tips because of all the people that hit the 20% button, 25% button, and 30% button, who tipped on top of surcharges, taxes, and tolls versus the Verifone ones who hit those buttons they didn't. This is the best government quote I ever got, by the way. We appreciate that work that went into his analysis and we're giving it a thorough read, said the New York City Tax and Limousine Commission. And what happened? Well, about 2 weeks later, they reprogrammed half the cabs in New York. So now all New Yorkers tip on top of tolls and taxes instead of just half of us. Oops. But at least it's uniform. We see things like the police department sending tweets about policy. Here's a great example. Hey, we've seen 115% increase in bicycle collisions. #bike space safety. That's the police department in New York. Turns out, like, first of all, 115% increase in collisions. I mean, you don't really see that kind of thing happen unless there's like a volcano that opens up or something. So I went and I looked at the data, and there was a decrease in collisions. Imagine if our government had to show their work. Imagine if every time something came out of their mouth, just like you do in school, you have to show your work. Like, why can't they publish a link to a Jupyter notebook along with this tweet? Like, that would be appreciated. Maybe one day. So I wrote about this and I pointed out there's a decrease, not an increase. Why? And I got this quote from the police department. But, that's how it works. We talked about this, and let me finish with two examples. One is this map I made of fire hydrants in New York, and these aren't just any fire hydrants. These are the most profitable fire hydrants in New York. What makes a fire hydrant profitable? Well, if you park within 15 feet of any fire hydrant, you get a $185 parking ticket plus a tow fee. So I decided to just, do a group by address. It's not that complicated. Do a sum and just count the total number of dollars that every hydrant generates per year. And I found a couple interesting things. First, on the Upper East Side is one of the largest areas where they give a lot of tickets. But more interestingly, on the Lower East Side is these two hydrants, and they were making over $55,000 per year. So that's $55,000 per year just being fire hydrants. They're literally making more than minimum wage being hydrants. Okay, it's kind of fascinating. How do these hydrants make so much money? Well, they're kind of there on the sidewalk, and then there's what looks like a bike lane between them and the car. And the car parks there. So that car right there is actually illegally parked because it's less than 15 feet from the hydrant. You could see in Google Street View, by the way, all the tickets that are on all the cars, which I always thought was fascinating over the years. When I published this work, I got this quote from the Department of Transportation. While the Department of Transportation has not received any complaints about this location, we will review the roadway markings and make any appropriate alterations. So I kind of rolled my eyes and didn't think much of it. But a couple weeks later, I went down to the spot, and sure enough, they had repainted the street. So, you know, we're starting to get actual street infrastructure change just by counting things, right? Just by summing things. This is not complex math. This is just adding things. And I'll give you this last example, which is this bizarre fact that in New York, parking in front of a curb cut, the little pedestrian ramp here, is actually legal as long as there's no stop sign or crosswalk. So if there's a crosswalk here or a stop sign, you can't park in front of the little curb cut. But if there is not, you actually can. It's a little weird. It was legislation passed by a pro-car legislator, you know, a while back. And I once parked in front of one of these, and I got a ticket. But I was a little, all right, fine, it's an easy mistake. So I pled not guilty. And what happened? I lost. So I appealed, and I lost. And so what did I do? I downloaded every single ticket ever given to anyone in New York City that had gotten this ticket. And then I systematically looked at all the most common places people got those tickets, and I showed that they were legal. And so that they were charging $3 to $4 million a year to legally parked cars around New York City from the police department. What did I do differently this time? This time I let the police department know about a month in advance before I wrote about it. I said, all right, just so you know, I'm going to write about this in a month, so be ready. And that way they'd have like a better response. And when I did finally release it, they put out this, the map of all the places, but they put out this quote: Mr. Wellington's analysis identified errors the department made in issuing parking summonses. It appears to be a misunderstanding by officers on patrol of a recent abstruse change to the parking violations. We appreciate Mr. Wellington bringing this anomaly to our attention. Thanks to this analysis and the availability of this open data, the department is also taking steps to digitally monitor these types of summonses to ensure they are being issued correctly. So they changed their monitoring, they issued refunds for those who asked for them, and hopefully made this all better. So I want to take a minute here to say, like, thanks to the availability of open data, right? It sounds like I'm a little adversarial with government, and I actually, part of that's just for I'm being silly here, but really I'm looking to partner. I think that people especially people with data skills can have a lot to add to society if we have partners within government that can listen. So, for example, like you can look at this and you can say, ha ha ha, the police department, ha ha ha, or you can say, hey, great job, police department. You released all this data, and now you've made yourself better by partnering with people. Like, that's a win, right? That's a win. How can we change our culture to work together so that when you better yourself by the public's input, that's a good thing, not a bad thing? I don't know. We got to get there. You probably need to get the New York Post to write less headlines, but if you do that, you can make those changes, right? So in summary, some tenets I spoke about for data storytelling: think outside the box, figure out what you're trying to say, explore the things you know best, keep it simple, convey one idea, connect with people. I read that backwards, sorry. And I'll end just by showing you some stuff my urban planning students have done who don't have any data science training, who don't have a background or are not fortunate enough to do some of the data science work that I know many of you have done, but still without those specific skills can still do things like use Excel and a pivot table and to create a view of what's causing the most traffic collisions in their neighborhood. Or this was a high school program where even without computer skills, people were able to start to understand how graffiti was affecting different neighborhoods around New York. Again, without immense skills in the data science space, but still able to use that open data to make a difference. So I'd argue anyone can be a data storyteller, and that's what I have for you today. So thank you.
The global clap for you.
Thank you. The singular, the lonely global clap.
So I can imagine for a person who likes to do improv that you are just loving the Zoom world that you're in, where you get all this instant feedback from your audience and you can adjust on the fly. So we will take questions for Ben. You can throw them into the Q&A and James and I will take a look at that. Otherwise, if you want to raise your hand in the participant section, we will take a look at that as well. And James can unmute you as needed for any questions. And while you're thinking of those questions, Ben, if you don't mind, I have a few, but I'll try to keep them limited here. So what about data dumps, right? So have we gotten to a stage in data science where, you know, you talked about putting out PDFs of data. It was still useful data in the PDFs, but I could make it much worse by putting out data in such a form that is all the open data, you know, and it follows the spirit, I guess you would say, of getting the data out there, but then becomes a nightmare to process and interpret, and it's missing the metadata, the headers, all the information, plus it's just garbage in, garbage out.
Right.
Is that something that you see in when you actually go scraping this stuff appear as a way to kind of slow down the data?
I mean, you know, it depends where this is coming from. So it's either going to be executive action or legislative action. And we've seen over the last, you know, many years that there are pros and cons to different approaches in government, right? The advantage that, you know, legislative action means that, hey, we made a law and you have to publish this. And that sounds like that'll stand the test of time, but it also means that the people in the executive branch are being forced to do it. When you're forced to do something, do you do it that well? Maybe not. So, you know, when it comes about through legislative action, you know, you're less likely to get clean data, data dictionaries, comments, you know. When it comes from, through legislative action. When it comes from executive action, at least it's your boss or your boss's boss's boss who's excited about it happening and is promoting it, in which case maybe you are more likely to provide all those beautiful things that you really need. So I've seen a mix of everything. I haven't seen someone like do something totally nefarious by putting some format that makes it possible to get. I don't think you'd have to have enough computer literacy to do that. So it's less that like people try to hide it and more how helpful will they be? You know, are they going to dump a bunch of codes and then not give you a dictionary? You know, what does this field mean? And what does the letter K mean? Like, I don't know. So there is a fair bit of that, but it's not like encrypted in a way that's impossible to get.
Let me ask a Q&A question here from Ed Schneider. It says your water quality map showed no problems in Manhattan. Could that be a function of Manhattan just being surrounded by rivers? So, and I'll just tack onto that question then is, you know, when you're interpreting this data and putting it in the form that you're going to tell your story about, you know, how deep do you need to go? You can answer this specifically, but how often is this going to happen, this type of thing?
Yeah, so around Manhattan, the larger the waterway, the less problematic dumping sewage into it. And it happens even Manhattan has basically the Hudson River and the East River are both quite large on either side. Whereas some of the other places that were a problem were things like creeks and canals. Never swim in a creek and a canal, I'll tell you that. That's why we saw that. The broader question is, you know, it is really, 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 really hard to prevent people from misinterpreting, to misusing your data. I do my best to highlight the caveats up front, though that doesn't guarantee that someone doesn't then write a headline that is in the opposite direction and makes you frustrated. So I try to put out the what is problematic with this. And I also kind of try to be humble and say, look, like my goal in this crazy exploration is to scratch the surface of things and add to questions that people should then, who like know this space, can go and dig in, right? Like I know nothing about fecal coliform, but somebody does. And maybe, you know, the people who work in that department now can take that and run with it and do something real. And maybe they're going to roll their eyes at me, or maybe it's a lead and they can go and fix something. So, you know, being humble and transparent about what it doesn't say is important. And yeah, it has to come first, but it still doesn't guarantee you that people don't misuse your information.
Sure, I get, you know, it's a process. It's just like science, it evolves.
Absolutely.
And that kind of relates to this next question that came up, is about kind of the reliability and accuracy of the data that you're getting from the FOIA requests. Are you able to do anything with that? I mean, a lot of times in computer science, you do truth tests, right? You have a gold standard catalog that you're comparing against, and you're making some real quantitative statement about how well you can trust the data. Is that possible even in the stuff that you're doing?
I mean, look, there's going to be noise in data. If the taxi data has some rides that go backwards in time, for example. So, you know, that tells you right there that there are suspect entries. the question you have to ask yourself is, is there a general liability? How much are these problems there? Like, and I generally, this is the data that government's using to function. So like, hopefully there's some sanity there. If I download parking ticket data, again, there are going to be weird dates. There are weird, sometimes there are cars that have registrations from 1904 and you're like, that doesn't seem right. But I have some faith that like there's a baseline cleanliness and that is what's being used to operate. And so I kind of put my faith in that. I agree that it's garbage in, garbage out. But like, and in the case of the permit data, for example, that is the raw data that the city gets. Now, there's interesting philosophical questions. Is like, if let's say you find a, like, if I wanted to fix the taxi data, and I want to say, hey, New York, your taxi data can I fix these rows? They're backwards. They actually want nothing to do with that, because as soon as they start editing data, it opens up all sorts of questions about what are they hiding. So they're actually much happier to pass bad data out than to try to change it to clean it, because that could be accused of data manipulation. So it's actually a really complex space. Who owns these? Who should own the clean version of this data set? Like, I don't know. Like maybe academic institutions. Maybe it's an interesting question, but not non-trivial.
No, that is very interesting, and I think of like the climate data, which gets adjusted all the time, because when they're taking temperatures in the ocean, it turns out the ship's engines heat up the water that's around the ship, right? And if you don't think about that, and then you have to go back and correct, and then people get suspect that you've actually manipulated the data, right? Which is really not the goal there.
Yeah, I will say that.
Let's see if there's nothing here. I want to ask one last question. I hate to. But I will. Okay, so you talk about the data and all the access to the data that you get. And I don't want to sound like this is going to sound a little bit like I'm being lazy, but it's really not. It's really about standardizing the tools that you use. So can we remove a middle layer, right? Where what happens is that multiple cities can sort of start to build libraries of the same questions that should be being asked all the time in different cities, and you're just modularly plugging in different data sets and spending your time on that library mapping.
Yeah, I mean, that would be amazing. As we know, standards are a hard thing to push unless you've got a lot of money and you're a giant. I mean, government has money, but like that you can just throw around and force your way in the front of something. So, I mean, let's take 911 data. It would be very hard to find two cities that have the same schema for that. Everything from the classification to the timestamps to the location to the way, I mean, it is a giant mess. So when you want to go and you want to compare city A with city B, you often can't do that in a fully fair way because they're using different schemas. They're using that. Some tell you some information, some don't tell you that information, right? Some have response time, some don't have response time. Some say, oh, it would be a violation of privacy to tell you the block this is on. Others say, oh, I can tell you the address. But not for these crimes, right? So I think that like ultimately, that would be amazing, but I think we're very, very far from that. And the other thing is that like, yeah, a lot of the users of this stuff tends to be the city themselves. So like one of the biggest users of New York City Open Data are New York City employees, because they need access to data to do their job, right? And it's much easier to get it from the portal than to call the other department to get this, get that. And so because of that, like who's going to enforce these global standards? Who's going to do that? Obviously, if we had some federal program where we've invested a lot in data science and we got everyone together, or some very massively well-funded machine to make that happen, it would be awesome. But it is so fragmented right now, and that seems like a long way off, even though it would be a dream.
Well, we can dream.
That's true.
That it happens. I'm going to keep it one more minute. I'm sorry, because we have one more question coming through, and I'll cut it off after this. But Jenny Zhang asked, do you think we should be teaching these skills more in schools so that the next generation has literally more data storytellers? And I think I'm putting the emphasis on the data storytellers. It reminds her of a problem described in a book called In Numeracy by John Allen Palos. So this idea of data storytelling as opposed to just writing the answer,
Yeah, I'll say two things. One is obviously we need more data literacy broadly. I think it's interesting, even in elementary school, right? You have these core subjects, but is thinking through data maybe should be elevated to certain, maybe, at least in the future society. I don't know. On the communication front, I also strongly believe that like our science curriculum lacks communication as a core part of it. If you're gonna go get a graduate degree in physics, at what point are you taught like how to communicate with people about that? You're not. I mean, you're writing academic papers for a particular audience, but how are you gonna, if you're a climate change scientist, you better be able to tell that story to politicians and other people, not just other people in your industry. And you're gonna have to use different vocabulary, and you're gonna have to be thoughtful about that. So I do think there's an opportunity there for science programs to stop and think about, the fact that communicating more broadly will leave a bigger impact, even though it's not necessarily the focus of these programs.
Yeah, and like you said in your talk, it's sometimes just about how you decide to make a figure, right?
Right.
It
Yeah.
can be bigger than that, but sometimes it's just, what is the figure you want to tell? What do those dots mean?
Yeah,
Don't swim
exactly.
here is a lot more important than the COI. So
Right.
thank you very much, man. Really appreciate
Pleasure.
it. It was a great talk. It was fun
Thank
to
you.
see. Learned a lot of information. Know where to go for data that I don't have time to analyze, but I love it.
And I'll put a plug. There's for those of you who, the quickest way to find some of this stuff is I don't, maybe people are familiar, but Google has a data set search engine now, which is kind of a great place to go to. You could type in, open data Detroit if you want, but you could also go to this Google data set search if you're just looking for data about a particular area, like birth rates or whatever, and you go there, and it's very comprehensive, and actually indexes all the open data portals along with all sorts of other data. But I found it a very useful tool if I'm looking at a very particular hypothesis. So it's a nice addition to the world of data set search.
Awesome. Thank you so much. All right. Thank you, everyone.
Take care. Thanks for having me.
See you, Ben.